Okay, this is sample 15.1.1, number 7. This will be a last of our double integrals. Okay, this one features some trig. It's got a variable limit and a pretty unpleasant limit here, the square root of pi over 2. I imagine, though, by the time we get there, it's going to work out okay. Okay, the inner integral, holding x constant, just integrating for y, is 0 to x squared, x cosine y dy. Of course, the integral of cosine is sine, so that's going to be x sine y evaluated between 0 and x squared. So the upper limit is going to be x sine of x squared, and the lower limit, because sine of 0 is 0, is just 0. So there's the argument for the next integral. The outer integrals are going to be 0 to pi over 2 square root of x sine of x squared dx. Okay, we could need to use a u sub here, but I'm just going to make a shortcut to it. I know that the integral of sine is negative cosine because the derivative of cosine is negative sine. So I need the negative here. So and then also we're going to need the derivative of the argument of sine x squared. So that's going to be 2x. So I need a negative 2 here. That's going to make this perfectly in the form. So I need a negative 1/2 outside to fix that. So now this is just, the integral of this is just cosine squared, cosine x squared. So it's negative 1/2 of cosine of x squared, and that's evaluated between 0 and the square root of pi over 2. And we can see why, even though that's an awful argument or endpoint, it actually works out quite nice. So the upper bound is just cosine of pi over 2, that's 0. And then minus the lower bound, cosine of 0 is 1, but it's minus 1/2, so it's a negative of a negative 1/2, so that's going to be 1/2. And there it is, 1/2 is the result of that double integral.